Hello and welcome to lesson 2.2 for Math 111. Last lesson we introduced rational functions and rational expressions, and we spent some time multiplying and dividing them. So we're going to go kind of the next place here, which is adding and subtracting rational expressions. Now usually when you first learn how to add, subtract, multiply, and divide, adding and subtracting were the easier of the two. But with fractions, what we find, or rational expressions, is that adding and subtracting are the harder of the two. And the reason for that is it goes back to that rule that you've had your whole life whenever you've dealt with adding and subtracting fractions. The same thing's true for rational expressions, is that to be able to add or subtract, you must have the same, or we say common, denominators. So we have to have the same bottoms to the fractions. That's what common denominators mean. For instance, really simply, if I gave you a rational expression that was very simple like this, like x over 4, and I wanted you to add it to 5x over 4, that is a piece of cake. Now, the reason it's a piece of cake is not just because these are simple, but because they already have the same denominator, 4 and 4. And hopefully you remember how to add fractions. I'm going to be really annoying and show like a whole extra step that you don't have to show. When you add two fractions, the only time you can add them is when they have the same denominators, and that denominator stays the same. It does not change. And then what we can do is put the two pieces together with the operation that we are doing. We're performing an addition, so we put the addition in between them. And then we can say, okay, well, x plus 5x, we can handle that. That's 6x over 4. Denominator did not change. Now, one thing that we always do with rational expressions is we need to look to see if it can simplify. We always check to see if it can simplify. And hopefully you see that, 6 and 4, let's see. I can turn 6 into 2 times 3 times x, and I can turn 4 into 2 times 2. And that gives me something that will divide out or cancel out. And then I'm left with 3x over 2. But don't get caught up in the simplifying yet. Just look at this first part. If I'm adding two fractions, if they have the same denominators, piece of cake. Just add the two tops. Keep the denominator the same. Nice. Now, like I said, we always want to simplify, so that's nothing new. We simplified last lesson. Sometimes nothing simplifies. What if I were to give you one like this, 5 over, let's go with something weird, like 7z squared plus, and let's just say it's x over 7z squared. Well, they have the same denominator, so I can add them. I can combine them into a single fraction with this same denominator, and I'm just going to say 5 plus x goes on top. Now, I can't combine these, so I'm done. Does anything simplify? No, nothing simplifies. And so that's really easy. I've added those two rational expressions. Now, of course, this is going to get way more exciting. For one thing, if this were a subtraction, I would have a subtraction here. And of course, I'm not always going to have the denominators already set, ready to work for me. But we'll hang on to that for a second. Let's do a few more examples. Let's be nice for another round here. Let's say I have x squared over x plus 7 minus 49 over x plus 7. And so this is our first subtraction, but there really is no difference with subtraction and addition. Well, one thing you can do to make sure you're not stressed over this is you can always go back to the statement I've claimed a few times throughout this course, is that there's only two operations, adding and multiplying. And I can turn any subtraction into adding the opposite. So I can always go add and make this the opposite sign. That's the same thing. You could leave it as a subtraction. Either way, notice that I'm very happy because they have the same denominators. So I can combine these into a single fraction over that same denominator. And this simple fraction or single fraction would be x squared either plus negative 49 or minus negative 49. It does not matter. They mean the same thing. I'm going to go with minus 49 and pretend that we didn't even bother with doing this. Let me put that back as a subtraction. So not a big deal whether it's a plus or a minus. Okay, so we've subtracted these two fractions. These are not like terms, so I cannot combine them. Now I do, once again, always need to consider simplifying, and it looks to me like this top may factor. And the reason that I automatically know it factors is that's a special product. That's a difference of squares. That's a perfect square minus a perfect square. So x plus 7 and x minus 7. And oh, that's exciting. I have something that will divide out to 1. And I'm just left with x minus 7. There's no need to put over 1. If you type it, I don't think I'll be very upset about it. But there's no need to do that. So x minus 7. So that's fun. That's not really that incredibly difficult. But then again, everything that we've done so far have already had the same denominators. What if we don't have the same denominators? How do we fix this? Let's take a look at an example like this. Let's go with 4 over x plus 3 minus, and we'll go with 3x plus 5 over, we're going to go with x plus 3 times x plus 2. So we no longer have identical denominators. So I cannot subtract or add these fractions yet. We can make the denominators the same, and we only have one tool that we want to use. One tool at our disposal. Okay? So that one tool is to look on the denominators and to notice that, hey, this has an x plus 3, this has an x plus 3. All that's missing here is if only this had an x plus 2 multiplied by it. Oh, well, what we can do is multiply the top and the bottom by the same thing, and then we would have the same denominators. Well, why does this work? I can't just randomly multiply by something. I can if I multiply by the top and the bottom on the same thing, because what I'm multiplying this by is x plus 2 over x plus 2. What is x plus 2 over x plus 2? Oh, that divides out to 1. So when I'm multiplying by x plus 2 over x plus 2, I'm multiplying by 1, and multiplying by 1 does not change the value. Does not change what this side is equal to. It keeps it equivalent. So then we know how to multiply rational expressions. That's what we did last lesson. So if I multiply x plus 2 times 4, I'm just going to write it as 4 times x plus 2. I could go ahead and distribute it, but I'm going to be annoying and take some extra time. And I multiply x plus 2 times this x plus 3. And then I just bring this side down because nothing needed to change over here. I now see that I have the same denominator. And since I have the same denominator, I can go ahead and do this as a subtraction. Now, before I do the subtraction, there's one huge tip I will give you. Because I have a subtraction here, I am subtracting off this entire chunk. Most people will go minus 3x plus 5, but this is subtracting all of this, so I strongly suggest that you put some parentheses. Anywhere there's any parentheses missing, once we start getting messier stuff, I suggest on the tops and bottoms of any fraction, anything that's just free floating like this, you add parentheses. They are what's called implied, and parentheses are understood to always be there, so we get lazy and don't often write them. But those parentheses are there, and if you don't know they're there and treat it like they're not there, you will make a mistake here. So let's take a look at what we have up top now. I'm just going to write it over. 4 times x plus 2 minus, I'm going to put these parentheses, 3x plus 5. Oh, well, this is simple. So I have this on the bottom. There's nothing to do down here. Let's see if we can simplify this top using just normal simplifying techniques that we've learned all the way back from very beginner algebra. And what I mean there is distribute whatever distributes in combined like terms. So I'm gonna distribute this 4. So I have 4x and distribute this 4 to the 2. So plus 8. I'm gonna distribute this negative. I could think of it as a negative 1. So minus 3x minus 5. There. Now let's combine these like terms and see what we get and see if there's any simplifying. There may not be any. We may be finished here. There could be though. All right, let's see. Like terms. 4x minus 3x is just x. 8 minus 5, that is a positive 3. Oh, okay. Well, it does look like, so I finished that. It does look like I have something that will divide out. And all I'm left with is an x plus 2 in the denominator. Oh, remember, you got to put a shirt on it. Okay, well, that is about, that gets into being about as big and nasty as we'll make these. I'll do a few other examples with you to make you cozy. I'll try to pull off one of the nastiest ones I can here in a second. But that's I went really slow breaking things down into steps you probably wouldn't do. You probably could jump from this green step down to this yellow step because you know that these are just going together. If you put these parentheses, you might say, okay, 4x minus 3x is x. 8 minus 5 is 3. Okay, so I went really slow, really meticulously careful, trying to make sure it wasn't super difficult. Let's do like 2 more examples. And then I'll be done with you. Okay, let's do one where I had to multiply both sides. So let's do one like this. Let's go with 3 over x plus 2 plus 2x over x minus 2. So I know the denominators look the same, but they are not the same. So what we're going to want to do here is we're going to want to just give both of these each other's piece. So here's what I mean. So this is x plus 2. If I want these to be like denominators, common denominators, I'm going to need an x minus 2 in this one. So I'm going to multiply the bottom by x minus 2 and the top by x minus 2. And the same thing over here. I have x minus 2, but I don't have an x plus 2. So I'm going to multiply the bottom by x plus 2 and the top by x plus 2. So this is just like multiplying by a form of 1 on each of these fractions. It does not change the value of them at all. It doesn't mess anything up. And so we're going to go ahead and be very careful with this. Actually, I'll be annoying again and just write it out what we have. So I'll write this nicer as 3 times x minus 2. And on the bottom, we have x minus 2 and x plus 2. Plus, over here, we have 2x times x plus 2. And we have x minus 2 times x plus 2. And yippee, if you look at the bottom, these are identical. Yay! So I can go ahead and do this addition. I know that the denominator will not change. It'll be x plus 2 and x minus 2, just like it is in both of these. Order doesn't matter with those. And then I can take my time to simplify these. Now I may want to distribute and then combine like terms. I can go ahead and distribute in this step to maybe make it go a little bit faster. That's 3x minus 6 plus 2x times x, so plus, that'll be 2x squared plus 4x. Okay. Now, do I have any like terms? Yes, I have, let's see here. I have 3x and 4x that are like terms. So if I write this a little bit differently, I can have 2x squared, 3x plus 4x is positive 7x minus 6, all divided by x plus 2 and x minus 2. Now, we're almost done. We just need to check to see if this simplifies, which means I need to try to factor this. If you wanted to, it might be good to kind of do some scratch work to try to factor it. We could do the AC method and do, or we could guess and check. But the AC method says take your A value, multiply it by the C value, that'd be negative 12. And let's see if there's anything that multiplies to negative 12, which would add to positive 7. Okay. Well, let's see. 1 and 12, negative 1 and 12 is not going to work. 1 and negative 12 is not going to work. Negative 2 and 6 is not going to work. 2 and negative 6 is not going to work. Negative 3 and positive 4 is not going to work. Positive 3 and negative 4 is not going to work. I don't believe this factors any. It's very tempting to think, because 7's here, and you're like, oh, 2 times 6 is 12, 3 and 4. That'll work. Because it's negative, I'm not going to have anything factorable. So we're done. So that didn't end up being too nasty. I can't factor that one. Not too bad. Okay. Now, let's do one last one that's like as messy, well, maybe not as messy, but as big looking as possible. Okay? And then we'll be done. So I could be as mean as something like this, where I give you 3x squared plus 11x plus 10. And on the bottom, we go with x squared plus 7x plus 12 minus 2x squared plus 5x plus 2 divided by x squared plus 7x plus 12. So I was nice. Notice I have identical denominators. And so it's very polite to you that this is not too bad. I can go ahead and know that the denominator here is x squared plus 7x plus 12. Now, let's do the subtraction here. Once again, remember that I got to be careful. There's parentheses here, so it's going to be minus the 2x squared, minus the 5x, and minus the, is that a 2 or a 7? A 2. Sorry, it's a little sloppy. So let's see. Like terms, 3x squared minus 2x squared. That's just plain x squared. 11x minus 5x, that would be 6x. And 10 minus 2, that would be 8. So, okay, we did the subtraction. That was not hard. We do need to simplify. So let's see if these will factor. Oh, these are both some of the simpler type of factoring, thank goodness. So let's see how fast we can do this. Two numbers that multiply to 8 that add to 6. Positive 2 and positive 4. Same thing here. Two numbers, let me write this down, that multiply to 12 and add to 7. Oh, positive 3 and positive 4. So does anything divide out? Oh yeah, x plus 4, x plus 4. So I have x plus 2 divided by x plus 3. So this looked big and intimidating, but honestly, it's probably the easiest problem we've done in a few examples. Anyways, that's not all that nasty, all that difficult. The hardest thing would be one where you have to multiply both sides to be careful to get denominators that work. But make sure you multiply by whatever it needs so that they become identical, and you multiply the tops and bottoms. Otherwise, give the homework a try, and if you have any questions, please email me. Good luck, guys.